All right, trust you did well on your quiz yesterday. Students in here did fairly well for the most part. Some little things here or there, so we addressed those. And obviously, if you're watching on video, hopefully your instructor addressed those with you also. We're going to take our next to last speed test of the quarter today. So speed test 26. Open up your speed drill booklets to page 11. You see some multiplication of fractions, some division of fractions. Remember, we don't really divide fractions, class. What do?
Multiply.
By the reciprocal. Which one do we flip?
The second one.
Just the one after, right? Never the one before the division sign, the one after the division sign. We also have some addition, subtraction. We got multiplication with decimals. Remember, be careful with your decimal places. And number 10 actually works out pretty easily, assuming you know your 12 times tables. But remember, when you divide by a decimal, got to make sure we move the decimal out of the dividend, out of the divisor the same amount of times. You're going to have 4 minutes for speed drill number 26, and you may begin. Stop. Pencils down. Get a pen out and exchange with the person behind you, person in the back. Bring yours to the front. Pencils down. Pencils off your desk, in fact. Pens out. And sign your name as grader, if you would, please. Next to where it says Speed Test 27, there at the bottom of Speed Drill 26. Sign your name next to where it says Speed Test 27, there at the bottom of Speed Drill number 26. Let's take a look at these answers. They are 10 points each. Some of these are really easy, some of them a little bit more challenging. Number 1 should have been easy to cancel the 5s. All you're left with is 4/9. 4/9, our answer. Number 2, you had to make that a 4/3 and then do just a little bit of canceling. Your answer should be 5/6. 5/6 for number 2. Number 3, we had to flip the 3/8, make it an 8/3. There really wasn't anything you could cancel. It came out to initially, 56 27s, but yeah, I can't leave it that way. 2 and 2 27s. 2 and 2 27s. Number 4, though, was a lot easier. Once you make that a 3/2 and you flip and make a times 4/3, evenly to 2. Really, really easy. Number 5, not too bad if you put the 15 over 1 first. There's just a little canceling you can do, make your life a little easier. You end up with 12.5 for your answer. 12.5, bless you, for your answer. Next row going across, we get away from the fractions, just some straightforward addition. Just got to be careful with our carrying. We end up with 3,197. 3,197. Number 7, just some subtraction. Be careful with our borrowing. Make sure we keep the decimal point lined up for our money there. End up with $886.78. $886.78. If they just forgot the dollar sign, just minus a point. Don't mark the whole thing wrong. Just minus 1 if they forgot the dollar sign. Number 8, when we multiply, we get 11,250. 11,250. Number 9, we just need to make sure there's 3 decimal places in our answer. 66.868. 66.868. And number 10, we end up making it a 21.6 divided by 12. Comes out to 1.8. 1.8. All right, they're 10 points each. Figure the total number wrong. Multiply by 10, subtract from 100. Put the score in the score blank. Also put the score, if you would please, where it says, next to where it says Speed Test or Speed Drill 26 on the score page. Yes, ma'am.
So, what if I forgot the decimal point in number 10?
On number 10, for now mark it all wrong, and I might reconsider, but for now take off all 10 points, because that's an important part of the problem. Good. Any other grading questions? All right, figure the score to the best of your ability. Oh, let's try not to hit the camera, gentlemen. All right. And person in the front, take it to the back. Person in the front, take it to the back. Everyone else pass forward to the person in front of you. And take a look at your scores. Any hundreds today? Any hundreds? Okay, how about 90s? Just missed 1. 80s? Just missed 2. All right, 70s? Just missed 3. Still not too bad. Questions? Which ones do we need to see worked, Michael? Particularly fractions. Again, we have an exam coming up. Are there any of these we need to see worked out? Yes, sir.
I just need to see, what is just the answer?
It's okay. As far as answers, I'll be grading it. So if, really the questions here are for process. I don't know how to do that problem, and I'm scared about the exam in the not too distant future. Elaine? Or she's Elaine. Jalen. Whatever your name is. You.
Number 1.
The first one? So we had the, was it a 5/9 times 4/5? I alluded to it when I was going over, but the 5s just cancel. All that's left on top is a 4. All that's left on the bottom is a 9. We're done. That easy. That should have been really straightforward. But hey, if we forgot, that's the way we remember for the exam. Ben?
5.
Number 5. Yeah, so remember the 15 needs to go over 1, and you multiply by 5, 6. Well, remember, you can't cancel the 15 and 5 because they're both numerators. But there's a 3 in 6 and a 3 in 15 you can take out. That makes it a lot easier numbers to work with. 25 halves. What's half of 25? Well, 2 goes into 2 once, nothing left. 2 goes into 5 twice with 1 left, and there's your 12.5. Yes, sir?
Number 7.
Number 7, just be careful on your borrowing to subtract. I mean, we've been doing that for a long time. Any other questions? All right, pass them forward if you would, please. Pass them forward if you would, please. And let's go and review. I got a chance to try my artwork, drawing some of these solid figures. And these 3-dimensional figures, quickly passing those in. These 3-dimensional figures aren't things you can technically draw perfectly, right? They don't but I can draw what hopefully is a representation so you get the idea of what's trying to be shown. With these solid figures, any flat surface on a figure is referred to as what? On a solid figure. What do we call I actually just used the term. No, I didn't. A flat surface is called a face. There we go. So as we look at this first figure here, I see 6 faces. I see 2 sides, I see a front and a back, and I see a top and a bottom. Same thing here, 6 faces. How many faces on this one, class?
5.
5. I got a triangle on the front and back, and then I've got 2 slanty rectangles and a rectangle across the bottom. How many faces on this one, class?
1.
Just the one. Just the bottom, right, which is the circle. The rest is kind of this weird wraparound job. What about this one here?
5.
5 of them. I got 1, 2, 3, 4 triangles and then a square, it looks like, on the bottom. This one here would have 2 faces, a circle on the top and bottom, and then it's just kind of one wraparound job. What about here?
0.
None. There are no faces on that figure at all. No flat surfaces. Where 2 surfaces come together, I get this little thing called an edge. That's literally a term for it, edge, right? I've got another edge here, I've got another edge here, I've got another edge here. Well, that's 4 edges, right? And I've got 4 edges on the other side as well. So that's 8 edges. I have 2 edges on the top that haven't been marked yet, and then 2 edges on the bottom. How many total edges
12.
do we have, class?
12.
12 edges. The same would be true in this next box as well. Still 12 edges. What about in this one? How many edges do we see?
9.
9. I see 3 on the front, I see 3 on the back, and then there's 1, 2, 3 that connect them together, right? Now, as I look at these edges, obviously we have this top edge here, and this edge, they all come together at a point right here. What do we call a point on a 3-dimensional figure? Yes, sir. A vertex. It's actually the same term we would have used in the plane geometry as well, but the edges come together at the vertex. So 2 faces, class, meet at an edge. 2 edges meet at a vertex. There we go. And of course we've got, let's see, 1, 2, 3, 4, 5, 6 vertices on that figure. This here and this are all the same all the way across, right? All the way back, all the way across. It's the same shape all the way through. In fact, you could even argue this has the same circular shape all the way through. What do we refer to, though? A shape that has a face that transfers all the way through, class?
Prism.
A prism. This prism has what for its basic shape all the way around, class? Rectangles. So this would be called a rectangular prism. Now this is also a rectangular prism, but if each side is a square, it's a special rectangular prism. We call it a cube. This one here has a triangle that carries all the way through, so we'd call this a triangular prism. Is this a prism?
No.
No, it comes to a point. If it comes to a point, it's not a prism. In fact, this is just kind of weird. It's got the circle at the bottom. It comes up to a point. What do we call that figure, class?
Cone.
A cone. Think an ice cream cone. Or a traffic cone. Or a cone that you're dribbling the soccer ball down and around in PE class. Anyway, over here, this also comes to a point. So it's also not a prism. But since it's triangles that meet at the top, it's not a cone. That would be called, class A, pyramid. And if the bottom really is a square, it'd be called a square pyramid. By the way, any shape can be used as the bottom. Right? It might be a little challenging to draw, but you could have, for instance, a hexagon where all the sides come up and form triangles. Now, in that case, you'd have a hexagon on the bottom. How many triangles would you have, class?
8.
If it's a hexagon, you'd have 6 little triangles that all come together, right? So it'd be a hexagonal pyramid. Okay, we're not going to worry about those in this class. We just have the square pyramid here. What about the one that's not technically a prism, but it's kind of like a prism? We'll look at it more today. We're going to circle the bottom, circle the top, just kind of follows through, class. Cylinder, there we go. And we said, by the way, for the cylinder, think of a can. If you take the wrapper off, it's always in what shape?
Rectangle.
A rectangle. So it's really going to be thought of as a single rectangle wrapped around a couple of circles. This thing, the thing that looks like a ball, class, we just call that a sphere. Good. With these figures that we see here, if we were to wrap the figure completely, the wrapping, or the space that would have to be completely covered, we refer to as the object's surface area. What do we call the space all over the outside of the object, class? Surface area. Now, in this case, we said there's 6 different rectangles, right? So the surface area is literally the area of all 6 rectangles added together. For the cube, it has 6 squares. So its surface area would be the area of all 6 squares added together. What about this one? Well, it'd be the area of the 2 triangles and the 3 rectangles all added together. You'll look at that more in pre-algebra. Really hard to calculate this one. What about a square pyramid? What would be the surface area? The area of the square, and then the area of the 4 triangles, right? What about for this? Well, it'd be the area of the 2 circles and the area of the wraparound rectangle. Kind of hard to figure out the sphere on that end. But the other ones, like, we could actually kind of figure it out or deduce the surface area. What if I just cared about the side? Now, I didn't want to do anything with the top and bottom, kind of like painting the walls, right? We don't want to paint the floor, we don't want to paint the ceiling. So we just took the walls. I ignored the top and bottom. That's called what kind of surface area, class? Lateral surface area. What is it, Ben?
Lateral surface.
Make sure you're paying attention, participating with me. The area of the sides, class, is just called the
Lateral surface area.
There we go. And so for the square, it wouldn't be 6 squares for lateral surface area. It'd only be 4 of them. For this one, we'd have 2 triangles, and then we'd have just the 2 sides, but we'd ignore the bottom. What about for the square pyramid? Its lateral surface area, class, would only be the 4 triangles. You would ignore the square bottom. For the cylinder, the lateral surface area, class, would only be the rectangle that wraps around. Look at that wraparound rectangle. Of course, you can't really have a lateral surface area for a sphere. I mean, it doesn't have a top and bottom. You can exclude it. So it's kind of one shape thing there. And of course, the math gets a little bit dicey. Again, out pre-algebra next year, you'll learn more about those ones. But we did have some formulas for the 2 box shapes that we looked at yesterday. And so for the surface area of the rectangular prism, we said that the bottom has a certain length and a certain width. But so does the top. It has the same length and width. So the area just of the top and bottom can be shown how, Michael? We're piecing together the formula here. We're reviewing from yesterday, Michael. We said the bottom has a length and a width. The top has the same length and width. So if I wanted to represent the area of the top and the bottom, we would say, Luciana, help him?
2LW.
2LW. And then the sides of the box have that same width, but they also have a height. Well, this one also has the same width and height. Back to Michael for redemption. How would I show the areas of the sides of the box? 2WH. And then if I want to take the front and back of the box, well, the front of the box has a length and a height. The back of the box has the same length and height. So, Bryson, the areas of the front and back would be 2LH. And there's our formula for the surface area of a box, of a rectangular prism. But what about the lateral surface area, sometimes just referred to as the lateral area? Well, we said we're going to exclude what, Jalen? The LW part, so we would just have what for our formula?
LA equals 2WH plus 2LH.
There we go. And again, do you have to put the 2WH before the 2LH? No, you could put 2LH before 2WH. Really doesn't matter, right? Addition's commutative. You can change the order up. But there's our basic approach to that. What about the cube, though? Well, we said the length, the width, the height, they all are the same thing anyway. So instead of specifying a length, a width, and height, we just chose to represent this length with what letter? Sam?
L.
No? Ben?
S-A.
No, well, that's how we represent surface area in general. Kirsten? E for edge, right? Because the length is an edge, the height is the same length of edge, the width is the same length of edge. So we said for the surface area of the cube, well, if this is edge, then the area of the bottom, class, would be edge times edge, or edge squared, right? The area of the bottom would be edge times edge, or
Edge squared.
but the bottom is the same as all the other faces, and there's 6 of them. So for the surface area of the cube, class, we have the formula SA equals
6E squared.
There we go. But with the sides, what if we only wanted the sides? Well, I don't use the top and bottom, so instead of using all 6 faces, class, I would now only need to use 4. So for the lateral area of the cube, let's come back to Sam, we would have 4E squared. Do you remember talking about this yesterday? Just kind of catching us up. We didn't have any homework last night, so we didn't get a chance to practice it or review it then. Wanted to make sure we remembered going over this yesterday. Any questions on that? All right. Page 199 in your textbooks. Page 199 in your textbooks. I'll leave the formulas on the board. I'll clear the rest of the space off so we can work. Why don't you look at the last two problems on page 199. Look at those last two problems on page 199. They tell us we have a cube with an edge of 7.5, was it meters? Yes, a 7.5 meter cube. And they wanted us to find the surface area and the lateral surface area. Well, again, class, the formula for the surface area of a cube is,
6e squared.
let's say the whole formula together now. SA equals 6e squared. Again, SA equals 6e squared. And for the lateral surface area, class, say the formula with me. LA equals 4e squared. Again,
LA equals 4e squared.
so for both formulas, class, the first thing I should do is what?
Square.
Square what?
The edges.
The edge, which in this case is?
7.5.
So we don't need to do it twice. Do it once, figure out what that e squared is, and then we can plug it into both formulas. So that's your seats. Go and multiply the 7.5 by the 7.5. Add your seats. Multiply the 7.5 by 7.5. Quickly working. Did you get 56.25? Should have. Make sure you're careful with the decimal there. Now, for the surface area, I'm going to take that number, class, times 6. Because surface area is 6e squared. For the lateral surface area, I'm going to take that number again, but now multiply it by 4. At your seats, find the surface area and lateral surface area of your cube. Did you find both answers? Surface area and lateral area? So multiply by 6 and then multiply by 4. And then, when you multiply by the 6, what did you get for the surface area?
I'm not even done yet.
Well, let's see where you're at. 6 times 5.
30,
And you carry the 3, right? 6 times 2 plus 3.
12,
Plus 3.
15,
15. Carry the 1. 6 times 6 plus 1.
37,
There we go. Good. 6 times 5 plus 3.
33,
And how many decimal places?
2,
All right, so Ben, what's the surface area?
337.55.
Do I need to write the 0? No, so I'm glad you just said 0.5. What would be my units for surface area, class?
Meters squared.
In this case, meters squared. Always square units because it's still area. Make sure you're working diligently on your own. I shouldn't have to walk you through the problem. You should do that on your own. What about when we multiply by the 4? Kirsten, what'd you get for the lateral surface area?
225
Comes out evenly, doesn't it? 225 what?
meters squared.
Meters squared. There we go. How many have both answers? Correct. Any questions on finding surface area or lateral surface area of a cube? Head off hand. Good posture. Give me good effort. Look at number 28. We have a rectangular prism. We've got a length of 12. We got a width of 6. We got a height of 4. So for this rectangular prism, we need to find the surface area and the lateral surface area. Again, length was 12. Was it 12 what, class?
Inches.
12 inches, okay. The width was 6 inches, and the height was
4 inches.
4 inches. Now, remember, the formula doesn't have to be perfectly exact, as long as you pair them up and double it, because there's 2 of each. So, without looking over there, Griffin, how might I write my surface area formula?
LW
But double it, 2LW, remember, because there's 2 length widths, okay?
plus 2W8 plus 2LH.
Good. He happened to say it the same way it was on the board over there. It doesn't have to be in exactly that order. He could have said, well, 2LH and then 2LW and then 2WH. Doesn't matter as long as you pair them up and double. When I get to the lateral area, though, it is important to remember, class, which of these disappears?
LW.
The LW part disappears. So it's just the 2WH and the 2LH. Again, they don't have to be in that order. You could say 2LH plus 2WH. Doesn't matter. Now, at your seats, plug in the numbers. Pair them up, multiply, and then make sure we double each time. And remember, there's a shortcut. Once you find the surface area, there's a shortcut to the lateral area. You don't have to redo all that math again. You done? All right, Corey, we're going to be real smart in the way we do this. I'm going to do a lot of it in my head. I can do 12 times 6 in my head.
72.
72. Now, doubling it, I may need to do on paper. I think you might be able to do 72 times 2 in your head.
144.
144 is right. Let's write that number down. Plus. All right, now let's do the WH in doubling. W times H, Elaine.
24.
Now double it.
48.
That was easy to do in our head. And now LH. We know that one also, Michael.
48.
But double that.
96.
96. Again, if you need to do stuff on paper, you can. But many of you, you've gotten good enough with your multiplication skills. You can do a lot of this in your head. Now it's just a matter of adding it all together. And when we add it all together, then back to you for redemption, what do we get?
I didn't know. I did the lateral.
Oh, you just did the lateral area. Okay, well, we actually want to save it because it's going to be really easy in a minute to get it. Let's go to Luciana. What did you get for the surface area?
288 inches squared.
Good, you add it all together, 288 inches squared. Now, Ben, what did you get for your lateral surface area?
160.
Close, not quite. Bryson?
144.
144 inches squared. But here's what I said yesterday, just by way of review, Ben. I said, go ahead and get the surface area first. But if you've written down all of these numbers, find your 2LW, wherever you wrote it, figure out what that number is, and just take it away. Because that's really, rather than doing more multiplication and addition and all that, you just take away 144, it's going to give you your answer, which is 144 inches squared. How many had both of these for number 28? All right, questions on those? Look across the page, if you would, right above that Christmas present, or some kind of present. I don't know. It's going to be wrapped, whatever it is. You see a little table there. Notice on number 10 on the little table, they give you a length, a width, and a height. Notice on number 11, they give you a length, a width, and a height. But what do you notice about the numbers on 11, class? They're all the same. So really, that's a cube. So you could just use the formulas. 6e squared, good, and 4e squared for surface area and lateral area, respectively. Same thing happens on 12, right? So you could use the big long one faster to use the other. Do 10 through 12. Find both the surface area and lateral area. Page 198, 10 through 12. Good. Some of you are like, I'm going to do 11 and 12 first. They easier. That's fine. Just don't forget your units, remember, as you write your answers. Just a little bit longer to be finishing up. And we'll take a look at these together. Let's take a look at these together. Bryson, number 10, they got a length of 3 feet, a width of 2 feet, a height of 2 feet. What surface area did you get? Let's pair the length and width first. 3 times 2,
6.
double that.
12.
Okay, now pair the 2 and 2,
4.
double it.
8.
All right, so I put the 3 with the 2. I put the 2 with the 2. The only pair I haven't done is the other 3 with the other, is this 3 with the other 2. 3 times 2,
6.
doubled.
12.
And we had those numbers together. Should have given us, anyone?
32.
32 square feet. What about for the lateral area? I'm going to ignore the first pairing that I did with the length and the width. Well, that would give me, Bryson, 20
feet. 12 feet.
square feet, 20 square feet or 20 feet square. Number 11, I probably just square one edge, class.
64.
64, and then multiply by 6 to get the surface area, Jalen.
My dumb self did 9 times 9.
9 times 9.
Yeah.
On number 11? Oh, Sam, helper, what's the surface area on number 11?
48 meters squared.
Oh, you did 6e. Not 6e, Sam. 6e squared. We got to square the edge first. So square the 8 first, then multiply that by 6. So not 6 times 8, 6 times 64. Ben, what did you get for the surface area on number 11?
144.
Not 144, Kirsten?
I didn't square it.
Oh, you forgot to square it too, Griffin.
I think I'm wrong. I got 96 meters square.
Oh, the pain, Corey.
442 meters squared.
No, yes, ma'am.
384 meters squared.
384 meters squared is correct. Oh boy. All right, and then for the lateral area, again, it's going to be 4e squared. So we got to square the 8, class.
64.
64, then multiply it by 4, and Elaine, what do we get?
256 meters squared.
256 meters squared. Tell you what, if you messed up on 11, redo 12 real quick. It shouldn't take you long. Redo 12 real quick. 6e squared, 4e squared. If you're good to go, sit there with a smug look on your face. Or just sit there. Got a good smug look back there, Kirsten. All right, so Sam, on number 12, we square the edge first to get, Sam, what do we get when we square an edge?
Oh, you get 25.
25, there we go. Then we multiply by 6 to get what surface area? Ben, help.
180.
25 times 6?
I don't know.
Kirsten?
150 feet square?
Well, not 150, 150 feet squared. Hey, 25 times 6, people. What's 6 times 5? 30. Carry the 3. What's 6 times 2?
12.
Plus 3.
15.
15. 150 feet squared. Okay, for redemption, Sam. 14 tries, just kidding. What did you get when you plugged it into the 4e squared for the lateral area?
I got 100.
Hey, there we go. 100 square feet is correct. Questions on these? Now, you're going to practice with more of these in your homework tonight, so be careful with your math. Before we move on, next thing though, let's move on. Flip back to page 196, and you see a picture of a cylinder that's kind of been opened out, so to speak. They've taken those circular top and bottom of the can and kind of set them to the side. They took the wrapper and they opened it up, no overlap there. And you see that they got a little rectangle with certain base or length and a certain height or width. So we see a little blue picture at the bottom of page 196. But notice the point that they make. How long is the rectangle that wraps around? What is its base? Whatever the circumference of the circle is, correct? The circumference of the circle is the length of the base of the rectangle. Now the height is whatever the height of the can is, correct?
Yeah.
If that's true, then the surface area of a cylinder is going to be the area of 2 circles plus 1 rectangle. It's a lazy way to say rectangle, okay? 2 circles plus a rectangle. Now, how do I find the area of a single circle, class? A equals 2 pi r squared. There you go. A equals what for a circle, class?
Pi r squared.
But there's 2 circles, so it's 2 pi r squared. Does that make sense? Now, the rectangle, remember, that's base times height, or length times width. In this case, the can actually has height to it. But if the base is the circumference of a circle, what's circumference of a circle, class? C equals pi d, or 2 pi r. Since I've already referenced r here, let's go with 2 pi r for the base or length of the rectangle times the height. That's the surface area. It looks, if you just try to memorize that on face value, it's like, oh, my head's going to explode. But if you remember, it's 2 circles. Well, you know what circles are. You know they're pi r squared. 2 pi r squared. If you remember that the distance around that 2 pi r is the base times height, it's not nearly as hard to remember. Does that make sense? All right, so there's going to be our formula for the surface area of a rectangle. Make sure you put a star next to that. You see that there at the bottom of page 196. What about the lateral area? Well, remember we said for the lateral surface area, class, we don't care about the top and bottom. So we don't care about the 2 circles. All we care about is the rectangle. So it makes sense then that the lateral surface area would be 2 pi rh. Does that make sense?
Yes.
All right. So make sure you mark that as well in your notes. Look at the example problem at the top of the next page. They give us a cylinder and they say that the radius of the cylinder is 4 inches. Bless you. They tell us that the height of the cylinder is 9 inches. Let's say together the formula for the surface area of a cylinder, class. SA equals 2 pi r squared plus 2 pi rh. Again, SA equals 2 pi r squared plus 2 pi rh. So we plug in the numbers. Here's our surface area. 2 times presumably 3.14, because there's no 7s in any of this. But if there were, I wouldn't use 3.14, class. 22.7, but there wasn't. And I can do the r squared in my head. What is r squared, class? 16. Plus 2 times pi times r times h. I think we can do r times h in our head.
27.
Oh, 36. There we go. All right. Now, I don't want to multiply pi until the last minute, right? Because pi is annoying. It's got decimals. What's 2 times 16? 32. So we're going to multiply a 32 right here. What's 2 times 36?
72.
72. And again, if you needed to multiply it off to the side, you could. You get 72. We're going to multiply that by the 3.14. Well, You all have probably figured out what 2 times 3.14 is already, right?
6.28.
628, right? And we're starting with a 2 in both cases, so we'll do that. Now, with the zeros, I gotta multiply a 3. 3 times 4.
12.
Here's the 1. 3 times 1 plus 1.
4.
And 3 times 3.
Nine.
All right, we're gonna add that together in just a minute. Come over here, 7 times 4.
8.
28 here, the 2, 7 times 1 plus 2. And 7 times 3.
21.
21, we'll add that together here in just a minute as well. So here we add 8 plus nothing.
8.
2 plus 2.
4.
6 plus 4.
7.
1 plus 9.
7.
All right, 2 decimal places. Plus, come over here. 8 plus nothing.
8.
2 plus 8.
10.
Here are the 1. 1 plus 6 plus 9. 1 plus 1.
2.
And nothing plus 2. 2 decimal places. And then we can add the 100.48, the 226.08. And notice the answer they get, 226.56. But we did still use a pi value that's approximate. So the surface area is approximately 326. Did they say 2? Oh, I was looking at the wrong number. 326.56 inches. There it is. Inches squared. Do you see how to solve it? It's a little bit more work because there's 2 different pi's that you have to work with. Get all the easy stuff first, do the pi stuff last, add it together. Questions on how they did the surface area. Now the nice thing is, remember for the rectangular prism, once we found the surface area, the lateral area was easy? That's the lateral area. Makes sense, right? The lateral area is just ignoring the 2 circles. So after you do all that work to find the surface area, for pity's sakes, don't redo the whole problem and find the lateral area. Just be like, well, this is the circles. I don't care about them. That's my lateral area answer. You literally are solving for both of them when you solve the surface area. Questions on that? All right, so let's suppose we have a large tuna can. How many like tuna? How many hate tuna? How many hate the smell of tuna? See, I actually don't mind eating tuna. I just don't like the smell. So if somebody else is eating tuna, it really bothers me. If I'm eating tuna, it only bothers me a little bit because at least I get to taste what I'm smelling. But I don't like to smell tuna unless I'm the one eating it. But let's suppose we have a tuna can. And let's suppose our can of tuna is 1.5 inches tall. And let's suppose it has a diameter of 4 inches. One of those numbers isn't useful, class. Diameter's no good to me, right? I want radius. So if you're told a diameter, just like the other times when we found a regular area, we need to cut it in half. So what is the radius of my tuna can, class? 2 inches. And of course, the height is the 1.5 inches. Let's say the surface area formula together, class. SA equals 2 pi r squared plus 2 pi r h. 2 circles, the rectangle, base, height. All right, so do we have any reference to the number 7, class?
No.
Rats, because then I could use 22 sevens. Okay, so we're going to be stuck using 3.14. We can square the radius in your head, but don't forget to square it. Several of you. With the e squared thing earlier. All right, don't forget to square it, because what do I get when I square the radius? 4. Plus 2 times pi. And I think we can do RH in our head, and this works out nicely for us. What do you get if you multiply 2 times 1.5? 3. So the decimal ends up not being too bad. Now, if the radius has a decimal, oh boy. But if the height has the decimal, it might get knocked out by the radius here. Well, we know 2 times 3, of course, class is 6. So we're really going to multiply by 6. Here, 2 times 4, class. So we're really just going to multiply by 8. So we multiply the 8 at your seats times the 3.14. And once Corey has it, he's going to tell us what he's got. Find the 3.14 times 8.
25.12.
25.12. And then we need to multiply the 3.14 times 6. At your seats. And we'll have Griffin tell us what he's got once he's got it.
18.84.
18.84. And for the surface area, we're going to take those two things, the area of the two tops and the area of the wrapper, and add them together. Now at your seats. Add them together. And what is the surface area? If I wanted to paint a tuna, wrap a tuna can as a gift, I don't know. It's a rough. Well, maybe, you know, if you were like giving a present to your kitty cat, right? Kitty cats like to eat tuna. Okay, so maybe you're going to wrap a little present for the kitty cat. That's why we're on to the surface area. We need to know how many square inches of wrapping paper we need. Jalen?
Yes. SA equals 43.96
43.96.
inches squared.
But since we used pi, we're going to say it is approximately equal. How many have the same answer as Jalen? Approximately 43.96 inches squared. Now, doing zero math now, if we just want to figure out what the surface area of the wrapper is, well, we use approximately again. Class?
18.84 inches squared.
Good. No math needed. It's already there for you. That is the lateral area, that second part. Questions on cylinder? All right, we didn't get a lot of time to practice with it in class, unfortunately. You're going to try just a little bit of this for homework. Tomorrow, we're going to review over all this. So tomorrow, nothing new. Tomorrow's kind of a practice day. Make sure we've got it down. No new formulas tomorrow. All right, work on making sure you memorize formulas, though. Your homework this evening is to do page 200. Page 200, numbers 1 through 5 and 17 to 19. 1 through 5 and 17 to 19. And a couple extra credit opportunities for you. On that same page, number 22 and 23 aren't things I specifically taught, but I think you could figure them out. So if you do and you get it right, you'll get an extra credit point on your exam for each problem you do correctly. So if you get both of them right, you get 2 extra credit points. If you get one of them right, you get 1 extra credit point. If you don't get any of them right, that's okay, no extra credit points. Do you have to do it? No. It's extra credit. So if you're like, I don't want to do those, you don't have to, but you have the chance to. Page 200, 1 to 5 and 17 to 19. And if you want extra credit, 22 and 23. Have a wonderful rest of your day. You are dismissed.